Hi everyone, welcome back to MAM Pathshala. In last video, we got to know the laser beam delivery system of LVF process. In my classification video, although we got to know all the type of additive manufacturing, but in today's video, as a recap, I am going to discuss about another popular and widely used metal additive manufacturing process, that is directed energy deposition, DED. So let's start today's video. DED, directed energy deposition. It is also known as blown powder method. In LPBF, we have seen the powders are spread over the build plate or the powder bed. But here in DED, the powders will be blown with the help of gas. So that is why it is also known as blown powder method. DED is also used for cladding. Cladding is nothing but coating of a particular material of few millimeter thickness over a part or component to just avoid any environmental reaction, corrosion, rust or oxidation of that material. So let's see the basic working principle of DED. So in DED, a substrate will be used over which the deposition will take place. Now a cladding head will be used. This is a cladding head. I have drawn a schematic of cladding head. In real, the cross section of cladding head is circular, not rectangular. So just for the sake of understanding, I have made this as a rectangular. So cladding head consists of many components. First of all, through the cladding head, the laser and the powders will come. So this cladding head consists of laser beam delivery system, which will include the optical fiber through which the laser will come, the lenses through which the laser beam will be focused onto the substrate. Also, to protect the lenses, a shielding gas is provided. So shielding gas will be nothing but some inert gas, argon can be used. So the shielding gas channel will also be provided inside this cladding head. Now at the time of deposition, when the laser will come and the powder particles will come, they will interact over the substrate. The substrate will be heated up, some portion of substrate will melt and the powders will be melted and deposited over the substrate. So this whole area is called melt pool or molten pool. And to protect the molten pool, to avoid any environmental contamination of this melt pool, a gas will be provided, which is called shrouding gas. This gas will just protect the molten pool. So that shrouding gas channel will also be provided inside the cladding head. To maintain the shape of the molten pool, a shaping gas is also provided. And this all three gases will come through a particular channel, and those channel will be provided inside the cladding head. Externally also, these gases can be delivered. Another important thing is the powder delivery. So the powders will be blown to the substrate. So obviously through a particular channel, the powder will be blown. So that powder channel will also be present inside the cladding head. So this is the basic components which will be inside the cladding head. Now let's see the cladding head bottom view, how it looks. Circular cross section in which centrally there will be a hole or slot. Through this slot the laser beam will come. A lot of circumferential slots will be present. Through these circumferential slots the powders will come with the help of carrier gas. All the gases will be inert gas. Argon can be used in all the cases. So apart from that, powders will come. Now in cladding, the laser can come through this cladding head and the powder particles can be delivered through some external channels at some angle. This can also be a possible design of DED. So this is all about the basic components of DED. As I said in my last video, this cladding head will be connected to a CNC, which CNC will be responsible to move this cladding head over this substrate. So this is the substrate. So the cladding head will move in this direction and deposit the material over this build plate. So I made a basic animation of DED. Let's look into this video. So the substrate will come. Through the cladding head, the laser will come through the central slot. Now let's assume the first design. The laser will come through the central slot of the cladding head and the powder particles will come through the circumferential slots. So this is the laser beam. This is the powder channel. They both will interact over the substrate, and after melting of the powder particles, they will deposit over the substrate. This is the deposited layer. So now as the cladding head will move in this direction, the whole layer will be made. Now the second layer will be deposited over the first layer. So there will be fusion between the first and second layer. So the process parameters used in DED will make sure that proper fusion between base plate and first layer with the second layer will take place. So now second layer is deposited. Now this is how all the layers will be deposited and the parts will be made. So this is the final part. Now after the part is made, this part will be removed from the substrate. This part will go for post-processing. Post-processing like heat treatments, polishing or coloring if it is needed, etc. etc. So this is how DED works, and this is how the parts are made using DED. So this is very well-known process for making metallic parts. We also learned about LPBF, which is also used for making metallic parts, and this is one DED. But there is a lot of difference between these two processes. As we can see, the working principle of these two processes are completely different. Apart from that also, there are a lot of other differences between these two processes. So in my next video, we'll see the difference between DED and LPBF, and we'll learn something more about the lasers which are used in DED and LPBF. So this is all about today's video. If you have any doubt, please feel free to comment down below. Let's meet in my next video. Till then, happy printing.